Let's look at an example then of the square wave. What we're going to do is to come up with a function to describe this square wave here, which is periodic between minus pi and plus pi, and then end up with a Fourier series here to represent that function. And the overall aim is to come up with values for A0, A1, A2 and so on, B1, B2 in front of these terms, and so then I can write down that series much like we did for the Lorentz series, and then enter that series into autograph and see whether or not that wave that we get looks anything like a square wave, which is what we're after. The first thing to do though is to define this square wave, define this function, so we can actually then find these values of A0, A1, A2 and so on. And this is here. So this first bit here is telling us that this function, the square wave function, is periodic. In other words, if I take any time t here, so let's take any time t along this period, what this is saying is that this function at time t is exactly the same 2 pi later. In other words, the value of the function at t is the same as at t plus 2 pi. So if I were to take this point, say, then 2 pi later, which is here, it looks exactly the same. If I take this point, and it's 4 volts for example, and go 2 pi later, again it could be 4 volts. In other words, it's the same values as we go along. It's periodic with period 2 pi. So if I were to carry this wave along this way, it would look like this. For the Fourier series to work, the function must be periodic with some period. 2 pi is commonly the period, and that must be the case because what we're going to do is end up describing this wave in terms of sine and cosine terms. So that's assuming it's periodic. In other words, it's got some sort of fundamental frequency and then the harmonics that follow on. So if it's not a periodic function, we can't use the Fourier series. So that's the first thing. It must be periodic, and this is telling us what the period is. Next thing is to define the function, and that's what this is doing with some inequalities in this case. So t, what this is saying is between minus pi over 2 and plus pi over 2, between minus pi over 2 and plus pi over 2, the value of the function is 4. And then it's also saying when t is between minus pi and minus pi over 2, in other words this region, but also between pi over 2 and pi, this region, the value of the function is 0. So these two statements define the function, the square wave that we're interested in. And we follow a similar process for any sort of function that we wanted to describe in terms of Fourier series. So now what we need to do is to find the values of A0, A1, A2, B1, B2 and so on. And to do that we use these integrals, which intend to try and come up with a value of the average over a particular cycle. And if you remember back to our integration techniques, the average is found by integrating over a particular period between pi and minus pi for example, then dividing by the period to get the average value. So this is what we're going to do. We're going to find A0 and then A1, A2, A3 and so on, and B1, B2, B3 and so on for this square wave. And the next video we'll go through that example.